Hi folks! Today I bring you a panel from a Sony device for which we fortunately have the model identification. In this case is ST-EX10. It uses one M66004 as a driver for VFD, which allows sending the character sequence in direct mode. We have already covered this family of the drivers like the M66003, M66004 and 5, but it is always worth exploring the possibilities of their control further. To do this, we will use the two rows of the keys present on the panel along with the Quadrature button to illustrate the possibilities that arise from bringing the panel back to life. Since we are using a specific code, it runs without library dependence, making it possible to isolate any function from the rest of the code. We use a pin where a trigger is implemented to interact with the Quadrature button. Some LEDs are controlled with buttons present in the panel, while other buttons call certain code functions. As we have two key lines, we will use two analog input lines in the Arduino to collect the values present on the lines. Each row of the switch original had 6 resistors, and I added 2 more, one as a safety resistor and one as a pull-up to the plus 5 volts DC. The process used on this panel is open state lines, and the project uses the resistors in the cascade mode, which allows saving one resistor. Since we are not concerned with the costs, I am trying to demonstrate both methods of using K-lines. This block here is both lines of the keys present in the panel. This is the line 0, line 1. In the code will be called line 1, line 2, okay? But is not relevant. And the alert I like to do is here, the first key present in the schematic of the panel don't have any resistor, okay? This resistor here is added by me in the breadboard. If you look to the schematic, they don't have a resistor implemented to the first key. After, the second note is they use a cascade sequence of the resistors. Okay? When you press the last button, you set the value present in the line to the head of all resistors present in the circuit. You can see here the value present. When you press this button, you implement 10550 with 330 in the line. This is the pull-up resistor, and of course you have here the voltage divider, okay? Exactly the same thing, and here in this side is a normal implementation of the set of the resistors associated with the key or the button. I like alert the difference from these both modes is here you can keep one resistor, okay? One resistor in the lot of the 1000 equipments represent money. By this reason, this implement is not so used, but we don't be worried about the cost of the circuit. By this reason, I suggest if you want to implement a line of resistors, you can use this mode, okay? The Quadrature button have assigned these both LEDs here, and when I turn the knob to the left or to the right, the LED will be active. At the same time, the count in the display will be changed. When I reach the 9, stay in the 9 because I only implement from 0 to 9 and 9 to 0. And you can see here the indicator of the movement to the right and now to the left. If I move the button slow, it's possible to let the both LEDs off, okay? This is the logic of the Quadrature button. The panel have 5 LEDs, and these 5 LEDs are controlled by the ports of the Arduino. And to control these 5 LEDs, I implement the logic in the buttons. The first button controls this LED here. When press, switch on. When press, switch off. The second LED, second button. Third LED, third button. When press, switch off. When press, switch on. Also, I implement the control of these two LEDs here, and for this we have let me see, it's not this, is okay, is this the button D. When I press the button D, I change the stats of this LED here, and the next is switch off, switch on, because this is a different logic, okay? Off, on, off, and when press, after we have the logic of these two ports here, switch on, the second LED switch on. This is red, this is blue, blue, red. These don't have actions. The connections to the Arduino is the pin 7 as a data, pin 8 as a clock, 9 as a chip selector, 10 is a reset pin, and after we have 2 output pins as a control of the directions of the Quadrature button. This 11 and 12 control these both LEDs here. The LEDs indicate the movement to the left or to the right. After we have the pin 2 and 3 as the input of the Quadrature buttons, 4, 5 and 6 is the control of the LEDs in the panel. Also, the analog pin A5 is used to control one LED in the panel, and the A0 and A1 is used to read the status of the key lines.